Okay, 7.3 double angle formulas. Okay, so double angle formulas can be derived from the appropriate compound angle formula. Okay, you can use double angle formulas to simplify expressions and to calculate exact values. Double angle formulas can be used to develop other equivalent formulas. Okay, I actually want to just go over the double angle formula for sine. Okay, so sine of 2x equals 2 sine x cos x. Okay, and if you think about where this comes from, okay, so if you think about the compound angle formula from yesterday, okay, so sine of a plus b, if we went sine of x plus x, because if you think about it, sine of x plus x is actually sine of 2x, right? 1x plus 1x, just add them together, it's 2x, okay? If we were to expand this using compound angle formulas, we would get sine x cos x plus cos x sine x. Okay, so if you actually think about sine, cos, and cosine, like sine x, cos x, sine x, these are actually the same thing, right? So with multiplication, you could do cos x sine x or sine x cos x. These are the same thing. You can multiply in any order. Okay, so essentially these are like terms. So since these are like terms, like sine cos plus sine cos is going to be 2 sine x cos x. And that's where that comes from. Okay, so now let's take a look at the other sine compound angle formula. Okay, so if you think about sine a minus b, like if we had like an x minus x, it would just be like sine 0. So like that doesn't actually make sense. So that's why there's only one equivalence, okay? So we wouldn't do like the subtraction, we would do sine a plus b. In other words, x plus x, 2x. Okay, now let's take a look at cosine. Okay, so for the cosine ones, again, we're dealing with cos 2x. So when you're thinking about cos 2x, you're thinking cos x plus x. Okay, so we have cos A, cos B. So in other words, cos x minus sine A, sine B. So in other words, sine x. So if you think about what's cos times cos, well, that's just cos squared. So we get cos squared x. Then what's sine times sine? Well, that's just sine squared x. Okay, so this is cos of 2x, obviously x plus x. After doing the expansion with the compound angle formulas, we get this first equation here. Okay, and then obviously the a minus b, that doesn't work for the 2x, right? Because we would have to have like a 3x minus x or something. That just doesn't work. Okay, so let's spin off of this. Okay, let's spin off of this. I'm going to actually sub in for cos squared x. Okay, so I'll bring down the cos 2x. For cos squared x, I'm going to sub in the Pythagorean identity. So if you remember, sine squared x plus cos squared x equals 1. And there's two spin-offs of this. There's one if we bring over the sine squared x, we're going to get cos squared x equals 1 minus sine squared x. The other spin-off is if we bring over the cos squared x, we're then going to get sine squared x equals 1 minus cos squared x. Okay, so if we go back here and we sub in cos squared x, this right here, 1 minus sine squared x, and then we're going to bring down this negative sine squared x. This would simplify to 1 minus, well, what's negative sine squared x minus sine squared x? Okay, these are the same, so they're kind of like terms. So we're doing negative 1, we're going to get negative 2 sine squared x. Okay, and then you can see that this is the third one down up here. Okay, and let's do the last one. So if we had cos 2x equals cos squared x minus, now this time let's sub in for sine squared x. Well, sine squared x is, bracket, 1 minus cos squared x. We will have to distribute this negative sign into the bracket. So cos squared x minus 1 plus cos squared x. We have like terms. We get 2 cos squared x minus 1. And that is our third equivalence for cos. Okay, so these double angle formulas do definitely come from the compound angle formulas. Okay, let's try the tan one. So we're going to go tan, instead of a plus b, we'll do x plus x, right? Because we want the tan 2x. So again, taking the compound angle formula, we're going to go tan x plus tan x over 1 minus tan x, right? Because we're subbing in an x for both the a and the b. So simplifying this, tan x plus tan x is 2 tan x, right? These are like terms, essentially. So 1 plus 1 equals 2. And then in the denominator, 1 minus, and if we have tan times tan, that gives us tan squared x. Okay? And then that's going to be 2x. And that is our double angle formula for tangent. All right, so example 1, simplify each of the following expressions and then evaluate. So I'm seeing this 2 sine pi by 8 cos pi by 8. So I can see that this is the same as here. We have x and x, but we also have pi by 8, pi by 8. All right, so look, these are the same, and x are obviously the same. We could rewrite this as 2 sine 2 times x, which is pi by 8. In other words, we can rewrite this as 2 sine. What's 2 pi by 8? I think it's pi by 4. And then, of course, we're just looking at 1 over root 2, sorry. Right, sine of pi by 4 is 1 over root 2. So our answer is 2 over root 2. Okay, for B, 2 tan pi by 6 over 1 minus tan squared pi by 6. So again, we see that the pi by 6's are the same, and for tan, the x's are the same. So we can actually rewrite this as tan of 2x, but the x value in our question should have written it pi by 6. Okay, so tan of 2 times pi by 6, which gives us tan of pi by 3. Okay, drawing the special triangle, pi by 6 is 1 to root 3. Tan of pi by 3 is root 3 over 1, so just root 3. And that's it. Okay, example 2. If cos x equals negative 2 over 3, and this is on the first rotation of 0 to 2 pi, determine the value of cos 2x and sine 2x. Okay, so when I see cos of 2x, or sorry, cos x, and I see negative 2 over 3, I'm thinking, okay, so on the first rotation, 0 to 2 pi, that's either going to lie here or here. Okay, so if this is our x value, negative 2, it's going to be here. 3 is going to be the hypotenuse, right? Because this is going to be adjacent over hypotenuse. Now let's do Pythagorean's theorem to see what the opposite side is. So we have like a squared plus b squared equals c squared. I'm going to go a squared plus negative 2 squared equals 3 squared which is 9 minus 4. So a squared equals 5. So a equals root 5. Okay, so this side is root 5. And this wants us to determine the values of cos 2x and sine 2x. So this is immediately what I'm thinking. This is just my visual. So let's even see if we need this. Okay, cos 2x. So cos of 2x, I'm going up here. Which equation do I want to deal with is the question. Oh. So we do have a value for cos x. So if we dealt with this middle equation, and again, all these equations are going to give you the same answer, so it's not going to matter which one you use. But if we say, okay, cos of 2x is going to be 2 cos squared x minus 1, here's the thing. 2 times, well, what's cos x? Because cos x, we're going to put in the ratio, and then we're going to square it, and then subtract 1. Well, we already have that ratio straight from the question. So if you make a mistake on like calculating this or doing the work, you may bring that mistake over here if you're using like the sine one, right? Like one of the double angle formulas for cosine, but with the sine in it. But this way, we haven't introduced anything new. So 2 times, well, what's 2 squared? 4. Was 3 squared 9, okay, and then minus 1. So 2 times 4 is 8 over 9 minus 1, which is 8 over 9 minus 9 over 9, and then that gives us negative 1 over 9. That's what I get. Okay, now let's do sine of 2x. So sine of 2x, we only have one formula for it. We have sine of 2x equals 2 sine x cos x. So here's where this differs a little bit. So in the previous one, we only dealt with the cosine, and cos, we knew that it was negative no matter what. Now, with the sine of 2x formula, we're dealing with sine and cos. So what ends up happening is we're going to have to go, okay, sine of 2x equals 2 sine x, and then we're going to have a cos x, which is negative 2 over 3. Okay, so that's fine. Here's the issue. This sine x, if in the second quadrant, this is going to be positive. If this is in the third quadrant, CAST, this is the tan quadrant, our sine is going to be negative. So we actually have to split this up because we're going to get two different solutions. We're going to get a quadrant 2 solution and a quadrant 3 solution. Okay, so in quadrant 2, so I'm going to bring this down here. So 2 sine x times negative 2 over 3. So in quadrant 2, this sine x is going to have a positive ratio. So sine x is going to equal root 5 over 3. That's it. Okay, so 2 times root 5 over 3 times negative 2 over 3. We multiply all of the numerators. So this is negative 4 root 5. We multiply the two denominators, which is 9. 3 times 3 is 9. Okay, now let's go to quadrant 3. I'm going to bring this down here again, 2 sine x, and then we know the cos x is negative 2 over 3. So this sine x here in this t quadrant is actually going to be negative. So the same idea, we're going to have negative 5 over 3 instead of positive 5 over 3, and then negative 2 over 3. And the same thing, multiply all the numerators. So I get positive 2 root 5, 4 root 5, my mistake, over 9. So two solutions. Okay, example 3, given tan x equals -3/4. So immediately I'm thinking, okay, where is tan negative? C-A-S-T. Tan is negative here and here. But here's the thing. It gives us a different domain. So it says on 3 pi by 2. Well, this is 3 pi by 2, and then this is 2 pi. So this domain is telling us it has to be in quadrant 4, which is the C quadrant. So it's not this one. Okay? Now we're not going to have two solutions for this because there's not two different ways to solve this. Like, it's only one quadrant. It's specifically, oh, I was going to put theta. It's specifically x in this quadrant. So calculate the value of cos 2x. Okay, so I'm a very, very lazy person. So when I think of cos 2x, the easiest one is to do this one here, where it's cos 2x equals 2 cos squared x minus 1. And the reason why I say this is because we only have to solve for one ratio. Oh, I mean, the bottom one you'd only have to solve for sine, but the top one you'd have to solve for cosine sine. So, okay, so let's figure out, based on x, tan is opposite, so opposite would be -3, and then adjacent would be 4. And I know this from experience, but this is a 3, 4, 5 triangle. Okay, so if you need to do Pythagorean's theorem, which is always good to put on your paper, -3 squared plus 4 squared equals c squared. Okay, so 9 plus 16 equals c squared, which is 25. Okay, so our c is 5. This is a common triangle, 3, 4, 5. Usually students learn it when you learn Pythagorean's theorem. Okay, so this is opposite, and this is adjacent, and this is hypotenuse. Cos is going to be, let's go back with this color. Okay, so cos of 2x is going to be 2, the ratio squared, and then minus 1. So adjacent is 4/5, 4/5, 5 being the hypotenuse. Okay, so 4/5 squared, 16/25. Okay, we're going to multiply the numerators. So 2 times 16, I get 32/25 minus 1. Okay, 1 with a common denominator is 25/25. So I get 7/25.